Hi friends, welcome back to my channel. In today's lab, we are going to configure HSRP with static routes in Cisco Packet Tracer. This is a very important concept for CCNA learners because it shows how to achieve router redundancy and failover in real networks. So let's get started step by step and make networking simple and practical. Friends, I kindly request you to subscribe to my channel, and if you find the videos helpful, please like and share. First of all, we will design the topology. We will use 4331 router, 3 routers. Okay, we will have 3 switches, 2 PCs. We'll give PC1 and PC2. We will consider this router as the active. We will give active R1. This is passive R2. This is R3. Give S1, S2 and S3, PC1, PC2. So we'll keep a server. Okay, we'll give a server. Coming to the connections. From R1, G0002, G000. Then from R3, G0012, G000. Now here we need to add one more interface on R3 to connect to S3. GLCT, and here we can connect from G0/0/2 to this S3. Then from active R1, G0/0/1 to our S1, G0/1, the same way from passive router to S2. Then we'll connect our end devices, PC1 here, PC2, and our server. Just I will arrange all our devices. Right. Here we will connect between S1 and S2 also, because whenever active the router goes down, it should communicate through S2 and passive. So we'll connect to G0/2, G0/2. Let me keep our topology left side so that we can view the addressing table while we configure. First of all, we will configure our active router, active R1. Enable configure terminal. We will set the host name, active R1. Now IP domain lookup. First of all, we will configure the interface G0/0/0, which is connected to R3. We will go to interface G0/0/0 and we will set the IP address as per the addressing table 10.1.1.1. Then subnet mask. So we use a /30. Then activate this interface. Then we will go to interface G0/0/1. We can see it is connected to our LAN. We will set the IP address as per our addressing table 172.31.1.2, then submit to mask. So here we can see we used second usable IP address because we can use any address, but still we did not use the first usable IP address. We will create that virtual IP address using the first usable IP address, right? So we will activate this interface by no shutdown. We will verify the configuration. Show IP interface brief. And here we can see the IP address we configured on both interfaces G0/0/0 and 0/0/1. Now we will configure the IP address on this passive router, that is passive R2. We will set the host name as passive R2. Now IP domain lookup. First of all, we will configure interface G0/0/0, which is connected to R3. And we can see this is another network. We will go to interface G0/0/0. As per our addressing table, IP address 10.1.1.5. Then submit to mask. Activate this interface. Then we will go to interface G0/0/1, our LAN, which is connected to S2. IP address 172.31.1.3. Then submit to mask. Activate this interface. We will verify interface configuration. Show IP interface brief. Perfect. Next, we will configure R3. Now, enable configure terminal. Let me give a host name R3. Now IP domain lookup. So here we will configure the interfaces. First we will configure interface G0/0/0. We can see which is connected to active R1. So here is the IP address 10.1.1.2. We given 1.1 on the other side. Then submit to mask. Activate this interface. Now we will go to interface G0/0/1, which is connected to our R2, passive R2. We will set the IP address 10.1.1.6. On the other side, we configured 1.5. Activate this interface. We will verify IP interface configuration. So we got one more interface. Before that, here we can see G0/0/2, which is connected to our S3, or maybe you consider this area as the internet area or ISP. So we'll configure G0/0/2 also. Interface G0/0/2. So as per our addressing table, okay, just consider it is towards internet. So we will set some public IP for this interface. For example, 202.128.1.1. Then submit to mask. Activate this interface. Now we will verify our interface configuration. Perfect. So we configured IP address on all interfaces in this intermediary devices. We are going to configure static route now. First of all, coming to this R1, we can see that this router R1 is not aware of this remote network. And in the same way, R2 also not aware of this remote network. So here we are going to configure a default static route towards R3 from active R1 and passive R2. So here we will configure our IP route 0.0.0.0 space 0.0.0.0 space. Okay, we will give exit interface G0/0/0. Okay, we are in privilege mode. This should be configured in the global configuration mode. Configure terminal. Here we will set that command G0/0/0. Perfect. In the same way, we will configure it on our R2. Exit interface is G0/0/0 towards internet. Configure terminal. We will give IP route G0/0/0. Now we will configure on R3. We will configure default static route towards our internet. And also we can see this R3 is not aware of our LAN here. So we will do that. Coming to R3, we will configure a default static route towards internet, our server. Configure terminal, IP route. So we will use exit interface G0/0/2. Now we will configure static route towards this LAN. So we can see we have a redundant path. We can reach to this LAN through active R1 or passive R1. So initially we will use this router active R1. Hence we will set the primary route through active R1 towards this LAN. We will configure IP route. So our LAN is 172.31.1.0. Then submit to mask. Then we will use exit interface, that is G0/0/0 towards the LAN. We will also configure floating static route, that is backup route through passive R1. Suppose this router active R1 fails, we should be able to communicate from R3 to our LAN through passive R2. So we'll configure a floating static route, IP route. So same network, that is 172.31.1.0, but it should go through R2. So here we can see exit interface G0/0/1. And we should set the administrative distance. So we'll give here 10. So here we will set IP address on all these end devices, PC1, PC2, and server. So consider this is as internet server, whatever. Okay. So we'll set IP address on PC1, 172.31.1.10. Then submit to mask. Default gateway. Anyway, here we did not configure HSRP. So for testing purpose, we are going to set the IP address of this interface G0/0/1 on active R1. So once we configure HSRP, we will change the default gateway. So here we will set 1.2. Then coming to PC2, we will set 1.11. Submit to mask. Then default gateway. Coming to our server, we will set 2.128.1.2. Then submit to mask. Then default gateway. Here we are going to see the services. HTTP. Okay, it's already on. Okay, perfect. Here we will test the connectivity in simulation mode. I'm going to send a packet from PC1 to internet server. So we can see it goes through active R1. Same way, acknowledges back to PC1. So we can see communication successful. The same way, we will ping from PC2 to internet server. And here also we set the default gateway through active R1. So this packet will go through active R1, R3 and to the internet server. So we can see that. Yes. We can see it is successful. Now, what happens if this router, I mean R1, goes down? So here we are going to shut down this router R1, or we can disable any interface here. Okay, so let me copy from run to start. Then we can shut down this interface, I mean this router. Now, if we communicate from PC1 to internet server, will it communicate? No, it will not. It will communicate. We need to reassign the default gateway because we configured our default gateway, the IP address of this active R1. Now we need to change it to this passive R2. So we should assign 1.3. And here in the same way, here also we need to reassign the default gateway. So reassigning the default gateway to all the entity devices are not practical. So for that we have HSRP. We will set the virtual IP and that IP we will set as the default gateway, and no need to reassign the default gateway on all the edge devices. Let me activate this router. and we will go to real time. Okay, now we are going to configure HSRP. So first of all, we will configure on active R1. Enable configure terminal, and here we will go to interface G0/0/1, and here we are going to configure the standby interface G0/0/1. Standby, we will set the version latest to standby. Next, we need to set a group number. So we will give 1. Then we will set the virtual IP. Here we will set 172.31.1.1. So this address, this IP address will be the default gateway in all the edge devices. Also, we will set standby 1 priority. We should set above 100 because by default it is 100. And let me set 255. Let me put a question mark, and here we can see 0 to 255 priority value. So we are going to give the highest priority. So this R1 will become the active router. And also we are going to set preempt. Suppose this router goes down and maybe come up after some time. So again he will become the active router by giving this preempt command. Next, we are going to configure in R2. We will go to interface G0/0/1, which is connected to our LAN, and we will set standby version 2. Then we will set virtual IP address here also the same, standby 1 IP 172.31.1.1. And here also we will give a standby preempt 1 preempt, and we are not going to set the priority because by default it's 100. So here we can see, so it's in standby mode. Okay, we will see that using show command. We configured our R1 as active router and R2 as passive router. So we can verify HSRP configuration using show standby brief. And here we can see interface is G0/0/1. We created the group 1, and we can see the priority we given 255, and state is active. Yes, he is the active router. So it is local. And we can see standby. So our R2 is the standby, and we can see the IP address 172.31.1.3. This is the address we given to the LAN, and we can see virtual IP. So this virtual IP we must use in all the devices as default gateway. Now we will go to R2 and we will see show standby brief. And we can see this is in standby state, and we can see the priority it is 100 by default. So who is active? Our R1. So 172.31.1.2, and the virtual IP we set the same what we configured on in R1. Now our topology is fully ready and fully converged. Now we are going to test the connectivity. Before that, we need to reassign our default gateway, because here we configured default gateway as 1.2. Now we configured HSRP, and we must set our virtual IP as default gateway, that is 172.31.1.1. The same way on PC2 also. We will test the connectivity. We will ping to our server. Let me get the IP address of our server. We are waiting for the replies. Yes, we get the replies. So we got 2 requests timed out. Don't worry about that. So there is a small delay in convergence. Now we can see for packet sent, for received. The same way we will ping from PC2. And here also we are waiting for the replies. Yes, it is working. Also we will access our web server from the internet. Yes, from PC1 also. Yes. How it works? We will check through simulation mode. We are going to send a packet from PC1 to internet server. Already we have seen this. It will go through our active router, then R3, then to the internet server. Then in the same way back through our primary route. And here we can see from PC2 to our internet server, it will go through only active router, that is R1, then R3, then S3, then to the internet server. In the same way, back to PC2, R3, primary route is R1, then S1, S2, and PC2. Coming back to real time, and suppose this active router is going down, and still we will be able to communicate to our internet server. So we set a redundant default gateway, right? So let me shut down this router. Copy run space start, and just I will shut down this. Okay. Before we test the connectivity, just I will go to this passive R2, and here we can see we received a message that it says state change G0/0/1 group 1 state standby changed to active, because now we can see this R1 is down and he become active. We can verify that. Show standby brief, and here we can see its state is active, priority is still 100, and we can see standby is unknown because it is already down. And the virtual IP we already set, and the same virtual IP there in all our edge devices, and surely these edge devices PC1 and PC2 will be able to communicate to our other networks. So just you can fast forward or you can wait some time, then we'll go to simulation mode, and we will test now how it works from PC1 to internet server. We can see it goes to S1. Now this R1 is down, so it will go to S2 and R2, then R3, S3, and internet server. Now coming back here in this R3, we already configured a floating static route, that is backup route. When this route goes down, it should go through this R2, and we can see it works. Yes, we can see it is successful. The same way, let me try from PC2. It will work, no doubt. S2, then passive R2, R3, S3, and internet server, and back to PC2 through our backup route. Perfect. Here, if we activate this router he will become the active, and this R2 will become passive, because we configured preempt here in this router, active also on passive. Just I will put on this device. So this router is starting. Just I will fast forward. Okay. So click on this passive. So here we can see that message state change G0/0/1 group 1. We can see now it is in standby because this router is up. Because of preempt, this router become active. And here we can see that G0/0/1 group 1 state standby active. Show standby brief. And here we can see active. Perfect. Right. That's it for today's lab on HSRP with static routing in Cisco Packet Tracer. I hope this tutorial helped you understand how redundancy and static routing work together in Cisco networks. If you found this video useful, don't forget to like, share, and subscribe to stay updated with more CCNA Packet Tracer labs and other technical videos. Thanks for watching, and we will see you in the next video.